Good morning, everybody. Welcome to Tibbetts Physics Regents Review. Today we're going to conceptually look at the force of gravity and the electrostatic force. So let's start by looking at both equations because they're very similar. F sub g is equal to g m1 m2 over r squared, and F sub e is equal to k q1 q2 over r squared. In this case, m1 and m2 are the mass of the objects, and r is the distance between the two objects. q1 and q2 are the charges of the objects, and r is also the distance between the centers of the objects. G and ke are both constants, and we'll look at those at the next video. So thing number one that we need to know about both of these: the force of gravity is only an attractive force. So you'll always have a positive force of gravity. However, Fe is both attractive and repulsive. So if we have a positive and a positive charge next to each other, that's repulsive, that's positive. If we have a negative and negative, that's also repulsive. But if we have a positive and a negative charge, then they're attractive, which would be a negative force. Thing number two we want to look at is the relationship between the force and the distance between each object. So let's remove all the constants. So we have Fg is now proportional to 1 over r squared. And same with Fe. Fe is also proportional to 1 over r squared. If we look at these graphically, we'll have the force Fg or Fe on the y-axis and the distance between the two objects on the x-axis. And we know that the farther away you get from, let's say, the sun, the weaker the gravitational field strength is. Same with charges. The farther you get away from the charges, the weaker the electrostatic field is. So the relationship is inverse, and it looks something like this. That's a common question that will be asked. Now, let's look at another scenario. We're often asked to find the relationship between what happens to the force as a distance increases or decreases. So number three, let's say the distance between the objects is tripled. So r now becomes 3 times as great. We should know in our heads that the farther away you are, like we just said, the weaker the force gets. So how much weaker exactly is what we'll look at. So all we do is start off with the equation. Fg equals g m1 m2 over r squared. We do the same thing with Fe if we wanted to. Now we're only looking at the relationship between Fg and the distance. So we'll get rid of all the constants. So just like before, Fg is proportional to 1 over r squared. In this case, r is 3. So it's proportional to 1 over 3 squared, which is 1/9. So the force of gravity would weaken by 1/9 when the objects are 3 times as far away from each other. Let's look at when they get closer to each other. So now let's say r is cut in half, so 1 over 2. We already have the formula. Let's look at charges this time. So we'll say Fe is proportional to 1 over r squared. K's and q's go away because they're constant. Fe is proportional to 1 over 1/2 squared. And we should know when the objects get closer together, the electrostatic force will strengthen. So our number should be bigger than 1/2. But we should do it in our calculators. 1 over 1/2 squared is like 2 squared, which is equal to 4. So it's 4 times as great. So really quick, Fg is attractive, Fe is attractive and repulsive. They're inversely proportional to the distance between them. And our graph looks like this. when we want to find how much the force weakens or strengthens based on the change in the distance, we just plug it into our formulas, getting rid of all the constants. And that's it. Hope you found that video. If you did, please like and subscribe. See ya.